Consider this logical argument. Some MTech students are good at programming. All those MTech students who are good at programming are also good at Carnatic music. All those who are good at Carnatic music, all those MTech who are good at Carnatic music are also good at research. This is what given to us. Therefore, some MTech students are not good at programming. So we may get claim like this. So something like this is given to us. We wish to know, does this claim follow from this? We may ask for a different claim as well. Some MTech students are not good at research. Something like this. So from this argument, can we conclude this? The approach is this. Translate all of this into FOL, this also into FOL, and check whether this premise consisting of these three statements, does this imply conclusion? We know how to write FOL for simple statement, compound statements. Follow that writing style. Convert this into FOL. Because the context is with respect to MTech students, we can fix UOD to be set of MTech students. So first one says there exists X. X is good at programming. And all those who are good at programming, they are also good at Carnatic music. X is good at Carnatic music. And all those who are good at Carnatic music, they are also good at research. Now, you may wonder, and conclusion is not making use of Carnatic music and research, then why these things are part of premise? That we need not bother. In the sense that premise consisting of some sequence of statements, conclusion may relate all of them or may take a subset of that or may not be related at all. Okay, so in fact the objective of this is to check whether conclusion follows from the given premise. Not all facts may be used in arriving at this conclusion. Okay, now we want to know, with this, can we conclude there exists X who is not good at programming? Okay, can we conclude from the given fact? Okay, so that's precisely what we are interested in. So here is a simple counter example to this claim. Let's assume this represents set of MTech students, and here is a picture that tells you that all are good at programming. Assume all are good at programming. If all are good at programming, then it also means some are good at programming. So this picture is captured. Since the conclusion is not involving these two, we need not look at this at all. Then concluding that there exists a student who is not good at programming is false. Here is a counterexample. A simple Venn diagram showing that all MTech students are good at programming. Such a picture is possible. And although we say some are good, it may be the case that all are good at programming. If all are good at programming, some are good at programming. Fine. So this picture is captured. Premise is true and conclusion is false. So here is a counterexample. Let's look at the following conclusion. Premise remains the same. I want to conclude that some MTech students are good at programming and research. So given this premise, I want to conclude that some MTech students are good at programming and research. How do we prove this? Let's perform existential instantiation so that the first one becomes programming of A for some A. Please note, if you want to simplify, then predicate should be converted into proposition before we employ well-known identities, equivalences and so on. Then I go for universal instantiation. This becomes programming of A implies Carnatic music of A. This is for any A. Again universal instantiation. Carnatic music of A implies research of A for any A. So remember, P implies Q and Q implies R implies that it is P implies R. This is a tautology. P implies Q and Q implies R. We see that P implies R. So, which means on simplification, we get programming of A implies research of A. And please note, these two are with respect to for any A. So, which means this is also with respect to for any A. Fine. Now, let's look at this again. We also know that P and P imply Q implies Q. This is a tautology. So we have programming of A and programming of A implies research of A. So we have programming of A, that's my P, and programming of A implies research of A. So this is P and P implies Q. Therefore, we conclude research of A. Please note, one of them is with respect to some, the other one is with respect to any. So which means some will take the preference. So this is true for some A. Because I cannot write any A. This is not true for any A. So this is only true for some A. Since this is true for any A, this is also true for some A. Now the scope of this is with respect to some A. Then what we can conclude is research of A for some A. Fine. Now that we have research of A and we also have programming of A, you can write programming of A and research of A for some A. Now go for existential generalization. We get there exists X, programming of X and research of X, which means some MTech students are good at programming and research. Therefore, the conclusion follows. So the idea is this: given this premise, we want to know so and so conclusion. Some MTech students are good at programming and research follows or not. So to simplify this, convert this into proposition by employing existential instantiation and universal instantiation. So this says programming of A for some A. This says programming of A imply Carnatic music of A. This says Carnatic music of A imply research of A. Now all are propositions. Use well-known identities to simplify. Here is one. P implies Q and Q implies R implies P implies R. So if you combine this, we get programming of A imply research of A for any A. Now when you take this and this, you can conclude it is research of A. Please note, because this one is with respect to some, and so the entire expression is with respect to some. So on one side you have programming of A for some A. On the other side you have research of A for some A. Therefore we conclude that there exists X, programming of X and research of X. Okay. Now on existential generalization, we get the desired conclusion. Please note the A that we use here and the way A that we use here are one and the same, which is why we are able to generalize this to this expression. Okay. We say for some A, the A that is used here and here, it's one and the same. So now this is precisely our goal. If it is false, you come up with a Venn diagram showing it is false. If it is true, use well-known identities which we discussed in the context of propositional logic. So the first step is to convert predicate to proposition, employ well-known identities and simplify.